Hey guys, welcome to another easy LeetCode question. Today we're going to solve the symmetric tree question. So this question gives you a binary tree, and then you should check whether this tree is symmetric. So what exactly does a symmetric tree mean? So if you take a look at the tree we have in front of us, we have nodes 1, 2, 2, 3, 4, and 4, 3. And then if you carefully put a line in the center here, you'd see that the nodes mirror themselves. So you see that 2 mirrors 2, and then 4 mirrors 4, and then 3 mirrors 3. So that's exactly what a symmetric tree is. If you put a line in the center and then you overlap them, the nodes are exactly the same. So this question wants you to see if you can, the thing that they're testing is if you can follow patterns in trees and then make tree traversals. So this is a simple question. So how do we solve this question? So if I was 12 years old, how would I solve this question? How would a 12-year-old person with no experience whatsoever in computer science solve this problem? So what we're going to do is look for patterns in the tree. So if you weren't given a symmetric tree in the interview, I highly recommend you make one up and then you check for patterns in that tree. So I've already drawn a symmetric tree for you, and now let's find patterns in this tree. So let's look at the first node, the root node. That's this guy right here. So we see that its right child is equal to its left child. So its right child's value is equal to its left child's value. And then let's take a look at the other nodes. So for this node, which is not the root node, we see that its right child's value is not equal to its left child's value. But oh wait, we see that this node's right child's value is equal to its left child's value. So you see, you have to determine patterns between those two nodes. So we've already determined that the right child's value is equal to the left child's value. So how do we translate that into recursive code that would work for almost all the nodes in the binary tree? So far we've discovered two patterns. We've discovered that the root node's right child is equal to the root node's left child. So we have to check for some sort of equality, and then we've determined that the every right child's right child is equal to every left child's left child. And then we've also determined, we're going to determine it right now, that the left child's right child is equal to the right child's left child. So I'm gonna move this tree over here, and then we're gonna write down the equality checks that we're gonna do. So we're gonna do about 2 equality checks. So we're gonna do an equality check to check that the right dot left that we're considering right dot left should be equal to, I don't have enough space, so what do? Right dot left should be equal to left dot right. So it should be equal to left dot right. And then what else did we determine? We determined that right dot right should be equal to left dot left. So right dot right, R-I-G-H-T, dot right should be equal to left dot left. So that's pretty much it. These are the 2 equality checks that we're going to check. And except for the root node, we only have 2 children nodes to check, so we're only going to check for those 2 children nodes if they're equal. So that's it. If you're given this question in an interview, all you have to do is draw up an example and then look at that example and try to determine patterns in that example. So that's it. Let's dive into the code. Oh wait, we have to talk about time and space complexity. All right, time complexity, pretty trivial, going through all the nodes in the binary tree. So it's an O of n time, where n represents the number of nodes in the tree. And then for space complexity, we're doing recursive calls that go as deep as the deepest node. So space complexity is O of d space. So time complexity, T is O of n time, and then space is D space. I didn't think about this, so comment down below if you think it's a different space complexity, but yeah, I'm sure. All right, let's dive into the code. All right, so we're going to recursively check if two children nodes are equal to each other, and then those two children nodes can change. So let's write up a recursive function, public boolean is symmetric, and it takes in two parameters, tree node, left, and tree node, right. And then we need to have a base case. So for the base case, we're going to check if the left node is null or the right node is null. So if left is equal to null or right is equal to null. So if this is ever the case, what we want to do is to determine whether the left child is different to the right, is equal to the right child. So we just return left equal to right. So if this is true, it would just return true. If this is false, it would just return false. So now that we have our base case covered, we need to process the recursive calls. So we're going to check if left.val is not equal to right.val. If this is the case, then we just return false. And then we need to process the next nodes that we're going to send in the recursive tree, or in the recursive calls. And if you can remember, we said something like, I have the thing right here. So right.left is equal to left.right, and right.right is equal to left.left. So we have to process these two equality checks in the recursive function. So we have to return whether is symmetric right.right, pass in right.right, and what's the next equality check that we're checking for? Left.left, and then and is symmetric right.left and left.right, right.left and left.right. So now we've processed this. It looks really good, really elegant, but we haven't accounted for the root node, which only has two children nodes, and then those two children nodes should be equal for it to be symmetric. So let's say if the root is equal to null. So this is something you might want to talk to your interviewer about. So if it's a null node, is it necessarily symmetric? I think it is. And for this question, that's a problem. It is symmetric if the root node is null, but that's something you might want to check up with your interviewer. So if I have a root node that is null, should I return true or false? So for this case, we're going to return true, and then we're going to call the recursive function is symmetric. And then what are we checking for the root node? We're checking if the left node is equal to the right node. So we're checking root.left and root.right. So that is pretty much it. We have to return this value since it's a Boolean. No, return. Just return right off the bat. We don't need to create an extra variable for that. Cool. Let's try to run this. See if it works. And yeah, it's accepted and it's really fast. And if you like this type of content, please consider subscribing to the channel and then comment down below if you have something to say. I always interact with the comments, and then like this video, share it around the community. And yeah, I'll see you in the next one. Bye-bye.